All right, today we're going to continue our work with trigonometric functions, and we're going to expand what we understand about trig functions a little bit. So you should still be using your terms: initial position, terminal position, standard position, coterminal angles, reference angles. We'll be using those words as we discover 3 more trig functions, so that takes us to a total of 6 trig functions. And you should be able to find those ratios. Remember, a trigonometric function represents a ratio of 2 sides of a right triangle. So there are 6 trig functions we'll come up with. You should be able to find that ratio given an angle, the terminal side with a certain point, or if I give you the right triangle, you should be able to come up with these things. So quick review of what we already know. We know sine of theta is the opposite over the hypotenuse. So the sine of a given angle is the ratio of the opposite side to the hypotenuse. The cosine of a given angle is the ratio of the adjacent to the hypotenuse. And the tangent of an angle is the ratio of the opposite to the adjacent. And the main idea is that it doesn't matter if I have a set angle, say 30 degrees, if I make my sides bigger or smaller, these are going to be similar triangles because I have 2 angles the same. And so the ratio of the opposite and the hypotenuse, or the opposite and the adjacent, or the adjacent, the ratios will stay the same regardless of how much bigger my triangles get. The ratios are constant for a set angle. Okay, and some people like to talk about this as being so, ka, toa. All right. So let's practice a couple. What is the sine of angle C? Angle C is this angle right here. So here's my opposite. Here's my adjacent. Here's my hypotenuse. Hypotenuse is always across from the right angle. Sine of C. And you have to write the angle. You have to give a name to your angle. It's not just sine. It's sine of an angle. Should be the opposite to the hypotenuse. So in this case, will be 8/17. Same picture if I want the cosine. I still have here's my adjacent, here's my hypotenuse. So the cosine of angle C is 15/17. Right? And then finally, tangent of angle A. So I have a new picture. Here's my angle that I'm interested in. So here's my opposite, here's my adjacent, and here's my hypotenuse. So tangent of A is the opposite side divided by the adjacent side. So no matter how, if I stretch or shrink this triangle but maintain angle A as being the same, the ratio of opposite to adjacent will stay the same. So our 3 new ratios. One is called cosecant of theta, and that's abbreviated CSC. You will need to know these abbreviations, but you will also need to know exactly what they mean. So cosecant of theta, secant of theta, and cotangent of theta. So those are our 3 new trig ratios. And so what do they represent? Cosecant of theta is the hypotenuse over the opposite, or it's the reciprocal of sine. Okay, the reciprocal of the sine function. So instead of doing opposite over hypotenuse, I do hypotenuse over opposite. Secant of theta is hypotenuse over the adjacent. It is the reciprocal of cosine. And cotangent of theta is the adjacent over opposite, or the reciprocal of tangent. And notice, if you think about these as pairs, every pair has a co in it. So cotangent and tangent, that's the easiest one to pair up because they both have the word tangent in them. Secant and cosecant, because every pair of reciprocal functions needs a co in it. And then cosecant goes with sine. Right? So that's one way you can try and remember. There is not a nice little SOHCAHTOA. I think if you try and do this, you'd get cho, sha, cow, and now we run into the trouble of which C is cotangent and which C is cosecant. So it's not as helpful. So I really like pairing them up with its reciprocal function and then think about what would I get if I flipped that original. So if we try one, cotangent of angle A. So here's A. Things stay the same, so this is still my opposite. This is my adjacent. This is my hypotenuse. Now you can memorize that, oh, cotangent is adjacent over opposite. I generally think of, all right, cotangent is the reciprocal of tangent. Tangent would be opposite over adjacent, so cotangent will be the reciprocal, which is adjacent over opposite. And there I get my 12/5. Cosecant of angle A, if I think about reciprocal of, it has a co, so what's the other trig function of our first three that doesn't have a co? That's sine, so this is reciprocal of sine A. And so sine is opposite over hypotenuse, so cosecant of A will be hypotenuse over opposite. Try one more. Maybe you should try this one on your own. Pause the video, see if you can get it. So in this case, we want the secant of angle A. So in my mind, that does not have a co, so I need one of my first three that has a co, that's cosine. So this is reciprocal of cosine of A. And cosine of A is adjacent over hypotenuse. So secant of A will be hypotenuse over adjacent. All right, so that is at the very basic level. Secant of angle D, what if our angle is in a different spot? Well, now this is my opposite. Here's my adjacent. Here's my hypotenuse. And so the secant of D is reciprocal of the cosine. So instead of 8 over 17, I will have 17 over 8. All right. So let's use our calculator to find a trig value. So we've done this. This should be fairly obvious. When we do sine of 52, it's really nice. You make sure that you are in degree mode, which I am not. So I should get in degree mode since I'm measuring angles in degrees. And then I just hit sine 52 degrees. And there's my answer. So the ratio of opposite to hypotenuse for a 52 degree angle will always be 0.788, no matter how big that triangle is. Right? Pretty basic. We've done this. How about secant of 22 degrees? How do I do that? I go to my calculator and I look for my lovely secant button, and it is not there, unfortunately. I see inverse sine right there. Oops, that's regular sine. I could do second sine is inverse sine. That's different than secant. Reciprocal and inverse are not the same thing. So what I want to do is I want to say, okay, secant is the reciprocal of the one with a co. I don't have a co, I need a co, so it's the reciprocal of cosine of 22 degrees, which means that secant of 22 degrees is 1 over cosine of 22 degrees. Now I have something I can do on my calculator. So if I clear that out, I can do 1 divided by cosine 22 degrees. And there it is, 1.078. Right? I could also think about doing cosine of 22 and then doing 1 divided by that answer. So there's two different methods to get my cosine or my secant of 22. All right, let's try another one. Cotangent of 37. So what do you think is going to happen here? Try it. I think about reciprocals. Cotangent, again, there's no cotangent button on my calculator. So cotangent of 37 is the same as 1 over tangent of 37 degrees. And that I can do on my calculator. So if we clear that out, I can do 1 divided by tangent of 37 degrees. There we have it, 1.327. Okay. All right, so now we're going to try a different type of problem. So we can calculate our 6 trig functions. We should know what they are. Now we're going to try and come up with them where we don't actually have a triangle, but I can get a triangle. So I want to find the cosecant in fraction form of a standard position angle with the point -6, 8 on the terminal side. So I want to draw a standard position angle that goes through negative 6, 8. Well, I need negative 6, 8. Okay, so here's my point. My angle goes through there. Now, I want to draw a little reference triangle. And remember, butterflies and bow ties, I don't want to draw there. I want to draw to the horizontal. We always go to the horizontal. And so the cosecant of this angle right here is going to be the same as the cosecant of that angle right there, using this as a negative 6 and this as an 8. So I've drawn my picture. So now cosecant of theta is the reciprocal of, let's see, I already have a and it's not the cotangent one, so I have the reciprocal of sine. So I need to know what my sine would be. Well, so I do opposite over, I'm missing a piece. So I need to find that hypotenuse. Now you could do negative 6 squared, and if you do that on your calculator, remember to put your negative 6 in parentheses. Plus 8 squared is c squared, and you can get 36 plus 64 gives me 100, so then c must be 10, or if you're good, maybe you did see that this was a multiple of 2 of the 3, 4, 5 triangle, so 3, 4, 5 becomes 6, 8, 10. So anyway, now we're back to our cosecants. Now I know my hypotenuse. I have all the pieces I need to figure out what my cosecant ratio is. The cosecant ratio for this angle in this triangle would be, instead of 8 over 10, it's going to be 10 over 8, my hypotenuse over my adjacent. Oh, opposite, sorry, not adjacent. Opposite, because it was the reciprocal of sine. One more, and then we'll jump into a new kind of problem. So a little more practice. Maybe you should try this one on your own, see what you get. So I'm going to do negative 6, negative 1. So there's my angle. So this big angle can be represented by the reference angle, which is right here. So here's negative 6, here's negative 1. And I want all 6 trig ratios for this one. So I definitely need my hypotenuse. 6 squared is 36. 1 squared is 1, so this is square root of 37. So, let's see, sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent, and those double negatives are going to cancel out, and we would really like it if you would write that as a positive 1/6. So then I have my cofunctions, right, my other trig functions. Let's move that over so I have some space. Sine's reciprocal is cosecant of theta, and so I'm going to be flipping. Root 37 over negative 1. Cosine's reciprocal is secant of theta, and that's going to get me root 37 over negative 6. And then cotangent of theta is going to be the reciprocal of 1/6, and I would get 6. Right? This up here I could write as root 37, negative root 37. And there we have it. I would like to talk a little bit about something like sine theta is negative 1 over root 37. So let's try a new page, because we're going to talk about rationalizing a little bit. Sine theta is negative 1 over root 37. We don't generally like radicals in the bottom. I understand 1/37th, but I don't understand how big 1 over root 37 is as easily. So we'd like to get rid of square roots if we can, and to do that I'm going to use a version of a 1 costume. Multiplying by 1 changes what something looks like without changing what it is. And there's all kinds of 1 costumes you can use. In this case, the 1 costume I'm going to use is root 37 over root 37. It's a pretty fancy 1 costume. The reason why I do that is when I multiply a square root by itself, I basically undo my squares and I end up with 37 on the bottom. And now I have negative root 37 over 37. I have what we called rationalized the denominator. I've made it a rational number, not an irrational number like a root. And then we would prefer that you do that on these problems. All right, so let's try. I've got one last example. 6 trig values for alpha. This is just another, it's a fancy way of saying theta. It's a variable, it's a Greek letter. Greek letters often are used to represent angles. Theta is one, alpha is another one. So if I know that cosine of theta is negative 5/13 in quadrant 3. So I'm going to start by using this information. I'm in quadrant 3, I'm just going to draw a triangle. Boom, I'm going to draw a reference triangle. And I know that cosine of theta is negative 5/13. Oh wait, I'm in quadrant 4. What am I thinking? Quadrant 3 is over here. That looks a little better. So I know that this cosine is adjacent over hypotenuse. So what that tells me is my adjacent side is negative 5, my hypotenuse is 13. I want to find the other ratios. I need to know my third side. Now in this case, I know my hypotenuse. So that's more like side B. So I could say negative 5 squared plus B squared is 13 squared. And I get 25 plus B squared is 169. B squared, I subtract my 25, and I get 144, and B is 12, which if you are good with your perfect Pythagorean triples, 5, 12, 13 is a Pythagorean triple that shows up a lot. So now I have all my sides, and I can find my ratios. So cosine of alpha we already have, so I don't really need that, although it might not be a bad idea to put that out there, because then I can do its reciprocal, which is secant, and I could have done this one without even drawing my triangle, because all I had to do was flip my cosine. So if cosine of alpha is this, sine of alpha is going to be opposite, so there goes my 12. Oops, what did I forget on my 12? I forgot to put a negative, which is very important, because in this picture, y being down here is a negative number. So sine of theta is going to be negative 12 over 13, which means cosecant of alpha is 13 over negative 12, or negative 13/12. Tangent of alpha, again, I'm going to have a negative negative. So I have opposite over adjacent, and my negatives are going to cancel, and that makes cotangent of alpha equal to 5/12.